Hello everyone, welcome to what will be our pre-lecture for lecture number 17. We're going to talk about some more chemical reactions and some of the math that we do around them. So getting into things, by the end of this class you should be able to define Avogadro's number, convert between moles and mass, and also a number of atoms. Should be able to define the molar mass of a substance and also use the mole and Avogadro's number to convert between moles and mass and number of molecules. And then finally, you should also understand the basics of dimensional analysis and how it can be used to convert between units with conversion factors such as molar mass. So before we get into the chemistry, I've had a number of people kind of ask follow-up questions on our grading system, and I wanted to take a minute to try and cover that for you and kind of review. So all this information was taken right from the syllabus that's present on Blackboard, and so just a reminder that instead of using points in this class, we use something called specifications. And so this is essentially a checklist for me at the end of the semester. I'll go through and check off all of the specifications you've done. Specifications can be related to our weekly quizzes, which you've done 4 of at this point, mastery quizzes, which you've seen the first of 4. We also have the lab portion of this course factored into the grade. So for an A, for example, you need a 93% or higher. Your homework assignments are, of course, factored in. All of you have already met this specification for meeting with me in the first 4 weeks of the course, so good job. And then we'll have a final exam. Final exam has 70 questions. You'll need to score at least a 48 on that in order to earn the specification for an A grade. And if we compare that with specifications for an A-, main things that change are you need less mastery quizzes, you need a lower grade in the lab, lower grade on homework, and a lower grade on the final. So that's kind of how we start to scale things, right? And so if we keep going down here, you can probably kind of guess how things change based on grades. So instead of an A or an A-, once you're at a B+, hopefully you notice that you need no mastery quizzes passed in order to get a B+ in this course. So if you don't even attempt a mastery quiz for the entirety of this course, you could still get a B+. I would, of course, recommend that you continue to attempt mastery quizzes as they cannot hurt your grade. Still need to pass all 10 of your weekly quizzes. We have a little bit lower lab grade, homework score, and raw score on the final exam. And then same is true for B. In that case, you only need to pass 9 weekly quizzes. You need an 83% or higher in the lab portion, 25 on homework, and a 40 on the final exam. For the kind of other end of the grade spectrum, so if we think about instead of A's and B's, maybe things aren't going quite as well as you wanted this semester. The bottom for passing, so a C- grade versus a D grade, still need to pass at least 7 quizzes of the weekly quizzes. Again, no mastery quizzes required. You need a 70% in lab, 21 on the homework, and at least a 30 on the final exam to pass. For a D grade, things drop a little bit further, so lower number of weekly quizzes, lab portion, homework, and of course the final exam score. Okay. One other twist in this is that we have a sort of currency system built into this, and so let me pull up a highlighter here and try and make this a little bit more clear. So these are all specifications that you are currently working to achieve. Mastery quiz is, of course, the most difficult of these, and so if you pass a mastery quiz at any point, you can use that mastery quiz to supplement basically any of these specifications on the far right column here. So you can, of course, count that mastery quiz as a mastery quiz. You can replace a weekly quiz with a mastery quiz. So say, for example, you just couldn't crack passing quiz 2 at any point this semester, but you did pass mastery quiz 1. You could replace that so that you no longer have that mastery quiz credit, but you've now maybe passed all of your weekly quizzes, which is the first goal. Okay. You can also use that mastery quiz to add 3% to your lab grade, add 3 points to your homework grade, or add 3 points to your final exam score. And of course, I don't want to just reward you for passing mastery quizzes, so you can also exchange a normal quiz for any of the things in this right column. If you get above or equal to a 95% on your lab grade, that also counts for any of these. So say you don't pass a single mastery quiz all semester, but you do really well in lab, you get 96% in lab, that would be exchangeable for a mastery quiz being passed, okay? Say you're also a stud at doing your homework, you get 30 out of 30, that could also count for any of these exchanges over here. Okay, and say you do super well in the final exam, that could also be exchanged for anything in this right column. Okay? All right, so hopefully that's helpful. If you have further questions on the grading system, of course, I'm happy to field them, so please let me know. And so with that, let's get into the chemistry. And so hopefully this slide looks familiar. It was from a couple weeks ago, talking about a mole. And so just a reminder that a mole is something like a dozen, but instead of being 12, a mole is 6.022 times 10 to the 23rd of something. This is something that we call Avogadro's number. So I'm going to be using that quite a bit in the pre-lecture and then in class today. Just as a aside, I would highly recommend you read what would happen if we had a mole of moles, aka what would happen if we had 6.022 times 10 to the 23rd moles. This is just a little preview from a blog, and so I have it linked there. I would recommend reading that if you have not already. It's pretty funny. So, getting into the chemistry of things, a question I might have for you is how much mass is in a mole of carbon and how much mass is in a mole of aluminum? And like a lot of things in Gen Chem, our answer actually lies on the periodic table. And so a mole of any element has the mass in grams equal to the atomic weight of that element. And so carbon's mass on the periodic table is 12.011 AMU. If we wanted a mole of carbon, we could mass out 12.011 grams of carbon, and we would have 1 mole. Same is true for aluminum. Obviously, it's a different element. It's going to have a different mass. And so that mass for aluminum is 26.982 grams per mole. And so this is a value that we call the molar mass. It's taken right from the periodic table. And so hopefully it should be a pretty easy thing to find. Okay, so that is the definition of molar mass, how we use it. We also are going to want to use it in dimensional analysis. And so dimensional analysis is a fancy way of saying unit conversion. And so we have an example here where if we have Avogadro's number, can be used to help us convert between mass and moles. And so say, for example, we have a diamond that, in case you didn't know, diamond is pure carbon, and it has a mass of 200.0 milligrams. My question for you is how many moles of carbon are in that diamond? How about the number of carbon atoms? And so if you want to take a moment, try and figure that out on your own. That'd be great. Otherwise, I will start to solve it right now. So couple things before we get going. I like to write out information that I have that I'm probably going to need throughout the problem. I've also underlined things. So we have 200.0 milligrams. I'm going to write out because, as we learned on the previous slides, we want to go between mass and moles, and I know that the way to do that is by using our molar mass. And so our molar mass of carbon is 12.011 grams of carbon for every mole of carbon, okay? And I'm going to express that as a fraction, like that. The other thing, if we need to find the number of atoms, in order to find a number of atoms or a number of anything, but in chemistry we tend to do atoms, I know that there are 6.022 times 10 to the 23rd atoms of something in 1 mole of something. Okay? So now my task becomes fitting things together so that our units cancel. And so that is, again, our dimensional analysis. Our goal here is to convert from units of milligrams to how many moles of carbon. So we need to have one answer that ends in moles and one answer that ends in atoms for our units. So if I set that up, I'm going to say we start with 200.0 milligrams. And if I look at my conversion factors over here, if I highlight a couple of things, I see that my molar mass, my units are grams, moles, atoms, and moles. And so I don't have any milligrams, but since I am a very smart chemist, as are you, we can convert between milligrams and grams, right? So we should know that if we want to cancel milligrams, we put it on the bottom. When we want to convert to grams, we put that on top. A reminder, doing this exercise, we put our 1 with the bigger unit. So in this case, our biggest unit is grams, because grams are bigger than milligrams. And hopefully you remember we have 1 times 10 to the 3rd milligrams for every gram. We could also say 1,000 there. Okay, so we've canceled our units of milligrams. Now we can use our conversion factor that brings in grams and convert it to moles. And so before I do anything else, I'm going to just cancel my units and set up my units. So if I'm in grams to start, I want grams on the bottom so that they eventually cancel, which means that I'm going to invert this conversion factor, this fraction. And so I put grams on the bottom. That means I'm going to put moles on top, and so and I'm adding the C there to describe that we're working with carbon. Okay, and so if I have 1 gram of carbon, getting off track there. I don't have 1 gram of carbon. I know that I have 1 mole of carbon. According to my conversion factor, I would have 12.011 grams of carbon. Okay. Then our units cancel, grams cancel, and we're left in moles of carbon. So at this point, I would just plug everything into my calculator. 200 divided by 1,000 divided by 12.001. When I did that, I got 0.01665 moles of carbon. So that is the answer to the first part of the question. If we want to figure out the number of atoms, because that was the second part of our question, we can just use another conversion factor. And so we have this other conversion factor right here, if my pen will work, where we have moles, so 0.01665 moles of carbon. And if we use another conversion factor, where this time we do want moles on the bottom, so 1 mole of carbon, then those will cancel. And we know we have 6.022 times 10 to the 23rd atoms of carbon. And so we take this number that we started with, we multiply it by our 6.022 times 10 to the 23rd, and I got a value of 1.003 times 10 to the 22nd atoms of carbon for the final answer there. Okay, so sorry it's a little sloppy, but I think you got it there. And that is how we would find our number of moles and number of atoms. So that's it for our pre-lecture. Hope that is helpful. If you have questions, of course, let me know, and I will see you soon.